this is Priyanka. Today we are going to understand the solar radiation at the Earth's surface. So before that, we will understand what is the different layers of the atmosphere. So if we observe here nearer to the Earth's surface, so this is the Earth's surface, this troposphere layer is there and which extends up to 7 to 20 km from this Earth's surface. Again, there is the stratosphere. So this layer is up to 50 km from the Earth's surface. Then the next layer is mesosphere, which is having the height of 90 km from the Earth's surface, and the last one is the ionosphere, that is the 350 km from the Earth's surface. So these are the different layers in the atmosphere. So when the sun's radiation passing through this atmosphere layer, there are different processes, that is the absorption and scattering. So why this absorption and scattering in the sun's radiation in this atmospheric layer? So because there are different gases that is contained in this atmosphere layer, as well as there are water vapors and particulate matters also. Now we will understand what are the characteristics of these layers. So if we move for this troposphere, now this troposphere height is 7 to 20 km. Now the 75% of gases contains in this troposphere layer. So whatever may be the gases in this atmospheric layer, that is this troposphere, stratosphere, mesosphere and ionosphere. So 75% of gases are in this troposphere. Now we will move for the stratosphere. So if we observe the stratosphere, it is up to the 50 km height. Now the clouds are contained in this stratosphere, and at the top layer of the stratosphere there is the ozone layer. So here this ozone layer at the top of the stratosphere, and above that there is the mesosphere and ionosphere. Now we will move for the solar radiation that is passing through these atmospheric layers. So what is happening when the solar radiation, so these are the radiation, and these radiation are called as straight radiation, or we will say here as the beam radiation. So when the solar radiations are called as beam radiation, so when the radiation received at the Earth's surface without change in its direction, then it is called as beam radiation. So we can say that this radiation is not changing its direction and it is received to the Earth's surface. So I will say that this is the beam radiation, or it is the direct radiation. Now what about the other radiations? Now if we observe, here is the ozone layer at the top of stratosphere. So in the radiation there is the harmful ultraviolet rays. So these harmful ultraviolet rays are getting absorbed by this ozone layer. So we can say that ozone layer absorbs the harmful ultraviolet rays. That means there is the absorption process. Now from the other beam rays, again there is the moisture and the gases are there. So moisture, that means we can also say here are the clouds. So due to the water vapor or these clouds and the gases, the radiations are getting absorbed. That means there is the absorption process. As we move away from this Earth's surface, the air pressure and temperature is getting decreased. Now there are different gases, that for example carbon monoxide, carbon dioxide, nitrogen dioxide, oxygen, methane. So because of these gases, the radiations are getting absorbed, as well as there are water vapors also. So due to this, the radiations are getting absorbed in the atmosphere layer. Now we will understand what is the diffuse radiation. The radiation received at the Earth's surface from all parts of the sky hemisphere after scattering in the atmosphere is called a diffuse radiation. So here it is called as the radiation received at the Earth's surface. So here is the Earth's surface and radiation received from the different directions from the all parts of sky hemisphere after scattering. So what is this scattering process? So this scattering occurs because of particulate matters in the atmosphere. So when this radiation is incident on these particulate matters, then this radiation is getting divided into number of directions, and it is called as scattering process. And when this scattered radiation reaches to the earth's surface from all directions, then it is called as diffuse radiation. And when we add this beam radiation or direct radiation and this diffuse radiation, then it is called as total radiation or global radiation. Now we will understand the concept of air mass. So the distance travelled by beam radiation means direct radiation through the atmosphere before it reaches location on Earth's surface is air mass, and its notation is m, and it is referred as capital A capital M, that is AM. So how we can write this? So we can write this AM is equal to mass of atmosphere through which beam radiation passes. That means we have to find out what is the mass of atmosphere through which the direct radiation, that means here is the direct radiation and here is the mass of atmosphere, divided by mass it would pass through if sun is directly overhead. So at every condition the sun is not directly at overhead, so we have to compare it with mass it would pass through if sun is directly overhead. Now we will understand the next term, that is the zenith angle theta z. So what is this zenith angle theta z? So it is the angle made by sun's rays with the normal to the horizontal surface. So we will understand this concept with the help of this diagram. So here is the angle made by sun's rays. Now this is the direct radiation, or we will say that is the beam radiation. Now if the sun rays is coming from this angle, then it is the angle made by sun rays. So we have to find out the angle made by this ray with the normal to the horizontal surface. So this is the earth's surface, we will consider here as a horizontal surface. And now what is the normal? Normal means perpendicular. So this vertical line will be the perpendicular to the horizontal surface. So angle made by this sun rays with this normal to the horizontal surface, that means this angle is theta z, is called as zenith angle. Now what is the relation in between this air mass and this zenith angle theta z? So we can say that AM is equal to air mass is equal to sec of theta z. Now how we can find out this air mass? So we have to first find out what is the zenith angle theta z. So when the sun is directly overhead, that means here is the beam radiation or the direct radiation that will reach to the earth's surface, and at that point this theta z there is no any angle, that means this angle is equal to 0. So when theta z is equal to 0, now we will put the value of 0 here, that is air mass is equal to sec of 0, and sec 0 means which is equal to 1. So this AM at theta z 0 we can say here as a AM 1. Now when this angle theta z is at 60 degree, so this if sun rays making an angle of 60 degree with this perpendicular or normal to the horizontal surface, then we will put here the value theta z is equal to 60 degree. That's why AM is equal to sec of 60, that is equal to 2, and this is referred as AM 2.